Hello everyone, welcome back to another lecture of COP-3402 system software. Today we're going to be looking at how we can translate simple IR instructions dealing with pointers into the corresponding x86-64 AT&T syntax assembly code. This is going to be the first of two lectures on pointer operations. So here's some review of what we're going to be going over today. We're going to be getting up to this section right here, section 4, dereferencing a pointer. We're going to save pointer assignments and some details on the stack frame layout for a later lecture. So pointer operations in simple IR. Simple IR has three different kinds of pointer operations. The first is getting the reference of a variable, the address of a variable. This is a reference operation. You probably are familiar with the syntax from C, so we use the prefix ampersand operator to get the address of a variable. And now what I'm going to do is move this over to my left-hand side so I can show you an illustration of this concept. So if we have three variables here, x, t1, and t2, and we assign t1 to the address of x, conceptually what this is doing, I'm going to delete this box here next to t1. What this is conceptually doing is saying that t1 points to x. That's why it's called a pointer. I'll make that a bendy arrow. That looks better. Now, let's go to the next operation, a dereference. What a dereference will do is go to the memory address stored in T1 and assign that value, the memory address, into the variable T2 in this code on the left here. So let's just assume, for the sake of this example, that x has some value. Maybe we'll say 8 in here. I'll make that blue so it looks better. So if we were to execute this code on the left, we would first go to the address in memory that T1 points to. So we're following this pointer. We arrive at x. What is x's value? X's value is 8. So we take 8 and we move it into the variable T2. That's how a dereference would work. And then we have a dereference assignment. So this is sort of like the inverse of a dereference. What we're going to do in this case is go to the address memory that a variable points to and then store a new value there. So we're saying get the value 11. So I'm going to copy this 8 here and change it to 11. And we're going to follow the address, follow the pointer stored in T1 to go to the address that T1 points to. T1 points to the variable x. We're going to replace 8 with 11. And that's it. Those are the three key pointer instructions we're going to be using, well, the only three pointer operations we're going to be using in simple IR, and the only ones that you'll be responsible for translating to assembly code with your compiler. And today we're going to be going over how to get up to how to translate a reference instruction. We'll go over dereference and dereference assignment in a future lecture on pointers. Okay, so here's a concrete example that kind of illustrates all these points of pointer operations. And we're going to step through this in this lecture. We're not going to show the assembly code for all of this, but we're going to walk through this example line by line with an illustration of the stack frame. So the code we're going to be dealing with. I'll go back to this shortly. Before we do that, just wanted to give a refresher here. Remember that local variables are stored as offsets from RBP. So we had said before, every variable is stored at some negative offset from the base pointer of a stack frame. So every function call has its own stack frame in memory. And variables are stored at negative offsets from the base of that stack frame because the stack grows downwards. So for instance, if we have these 7 local variables here, a, b, x, y, t1, t2, t3, they would be stored at these following offsets. You'll notice that each variable's offset is increased by a size of 8. That's because we're dealing with 8-byte integers in simple IR, only 8-byte integers. And words or memory addresses in assembly are byte addressed, so 8 bytes. That's why we decrement by 8 each time. And you might be wondering, why do we start at 16? Why don't we start at 0? That's because the application binary interface, which we'll talk about more later, just requires us to push some extra values onto the stack before we start storing the local variables, so we have to account for those. And we'll talk about that more later in a future lecture on function calls. But for now, all you need to know is that we start at -16 and we grow downward from there for local variables. And if we wanted to extract a value from a local variable, we just use an offset from the base pointer. So in this case, if we wanted to move the value of a into RAX, we would just say, give me -16 offset from the base pointer, so -16 RBP, and move that value into the RAX register, because the destination operands are the second operands in assembly, at least in AT&T syntax assembly that we're using in this course. So now for the fun part, a diagram of how memory looks like here, especially with these instructions being executed. So I'm going to drag this over just a little bit so we can fit everything in the screen. Okay, so hopefully you can see it all. Maybe I'll make that just a little bit bigger. Let's see if we can get that a little bit bigger. How does that look? Yeah, I think that looks good. Okay, cool. I'm going to go back to the example code now so we can see this as we step through it. So the code on the right here is a stack frame layout for this function call on the left. And this is an arbitrary memory address. We're choosing that the RBP is going to be at 120. I'm going to circle that here with a laser pen. This is not a guarantee. So just as a reminder, the address of function calls on the stack frame is going to be not known at compile time, or at compile time. It's going to be determined at runtime. And because of that, we have to access these variables as offsets from RBP. Now for this example, we're just going to assume that the address is 120. But again, you're not going to know the address of the base pointer, the exact address of the base pointer at runtime. So you can't because you don't know its exact address, you don't know the exact address of the variables here, and you'll have to, of course, use offsets in order to access their values. But for this example, we're just going to assume that the base pointer is at address 120 in memory. So this is in RAM. RAM has probably been virtualized. That's what we're dealing with. Okay, so let's go through this code on the left. The first thing we do is assign the value 8 into X. So we're going to go to memory offset -32. That's where X is. And we're going to move the value 8 into there. So let's draw that value. So I'm going to switch over to the pointer tool here. Copy this. Paste that in. And we'll change that to an 8. Okay, so the next value, or next instruction I should say, we're going to say y is equal to 9. So I'll copy this again, paste in the value 9, and I'll pop it in right here. The third instruction says that t1 is equal to the address of x. So what we're going to do is look at the address of x. Well, x is at offset -32. 120 minus 32 is 88. So 120 minus 32, 88. So we're going to say x has the address 88. So we're going to take the value 88, and we're going to store that value in T2. Now for this next instruction, we're going to say T2 is equal to the value in memory, the value that T1 points to. So T1 points to address 88. So what we're going to do, let me go back here. What we're going to do is take the address 88, go to that address, find the value 8 there, because that's what we last assigned to x, and that's what T1 points to. So 88, go there in memory, find the value 8, and then we're going to take that value and we're going to put it in T2. So I'm going to do that now. I'm going to take that value 8, we're going to put it in T2. And for this next instruction, we're going to dereference on the left-hand side now, dereference T1, and we're going to assign it to 11. So we're going to say, get the value in memory, or get the value T1 points to. So T1 points to memory address 88, go to that address, and store the value 11 at that address. So we're going to overwrite the contents of X effectively with 11. Now in T3, we just assign X, or T3 to the value of X. So we're going to say X is now equal to 11. So we're going to say that T3 is equal to 11. And then finally, we return X. So to do that, we move the value of 11 into the RAX register. We'll see more of that later during function calls. And that's it. That's the contents of the stack, what it should look like after executing all this code here on the left. Now, I'll mention this. in this example, I'm showing the variables as being between these lines here, but the memory addresses are actually next to the lines. In fact, the offsets here should probably be next to those lines as well. You can think of it more like these memory addresses are the intervals, and then the variables are spanning a region of memory. Because remember, variables are 8 bytes, but these are like specific addresses in memory, so it's kind of sometimes better to visualize memory this way, where each address is a specific line or partition of memory, and then the variables span regions of memory, because in fact, effectively they do. They span 8 bytes, whereas these addresses are only specific locations of memory. Okay, but let's continue to the rest of these slides for today. So assignment. How does assignment work in assembly? Well, we just saw an example. I'm not going to belabor the point. I'll just go back to the previous slide and show you. Here it was. Right here. So you can see assignments in assembly. We have the left operand. The first operand is going to be the source. The right operand is going to be the destination. So we're moving from some value, in this case, a -16 offset from RBP. Well, what is that? Well, according to the symbol table, which stores all our variables offsets from the base pointer, the variable A is at offset -16 from RBP. So in this case, we're moving the value of A into RAX. So that's a refresher on assignment. And now for the exciting part, something that's relevant for your compiler implementation. How do we actually translate the operation of getting a reference, getting an address of a variable, getting a pointer, a reference operation? Well, let's take a look at this example here. So the big idea of what we're going to be doing is starting with the base pointer, adding the offset of the variable that we're getting the address of, which is going to be negative because variables are stored at negative offsets from the base pointer. And then we're going to store the result in the left-hand side. So in this case, what we'll be doing is, let me zoom in. We're going to be getting the address of X. We're going to be adding, I'm sorry, not the address of X. We're going to be getting the base pointer. We're going to be getting the offset of X from that base pointer, adding the offset to the base pointer, and then storing the result in T1. That's the big idea. And let's see what the actual code here would look like for that. So if we assume we have the following offsets, according to the symbol table, so X is -32, T1 is -48. Let's actually write some code and see what this would look like. All right, sorry, my editor was acting a little bit weird there. Let me try running Vim again and see if this works. Okay, cool. We're all good. All right. So the first thing we need to do, let me actually write out the code here in a comment so we can have a refresher of what we're doing. All right, so I wrote down some comments so we can remember what we're doing here, and I'm going to actually write this assembly code. So the first thing we need to do is store the base pointer's address in some register for us to manipulate. So the address of the base pointer, we're going to be moving into another register. So we store values at the move instruction, so I'm going to use the move instruction here. We're going to be storing the RBP register, and we'll say just RAX. That's where we'll store it in. So this gives us the address of the base pointer, or the value of the base pointer. This is the address of the stack frame. So I'll go back to the slides real quick. Right here, maybe the drawing actually. this would be 120 effectively in our example here on the right. Now what we want to do is get the address of x. Well, what is x? X is at address 88. So how do we get x's address? Well, we can just add x's offset to 88. So why don't we do that now? So what we've done is add negative 32, which is x's offset from the base pointer, to the RAX register, which stores the base pointer's value. So this should now be 120 plus minus 32, 88. Now you might be wondering, why are we adding a negative? Why don't we just use a sub instruction instead to subtract 32 from the RAX register? And the reason why is because, remember the symbol table? I'll show it again here. The symbol table stores negative offsets. So in your compiler's code, when you're writing your compiler, we're going to give you the symbol table already, and it's going to be storing negative offsets because that's the normal way to store these offsets. You'll have to basically flip these offsets in order to use a subtraction instruction instead, so it's actually easier to just use an addition and just add a negative from the get-go. All right, so we're not done yet. So we've obtained the address of x. We've done this part here, getting the address of x. That's now in the RX register. But we have not yet put this value in T1. So now we have to do that. So what we can do is use another move instruction and move the RX register's value into, can you guess where? Well, it's going to be a memory offset. So it's going to be some offset from RBP. So we have to use the parentheses to signify an offset. And what exactly is that offset? Well, T1 has an offset of negative 48, so we use exactly that, negative 48 RBP. And that's it. That's how we can actually get the address of x stored in T1. So what we're doing is, again, we're moving the base pointer's value into RAX so that we can manipulate it. We're then adding negative 32, the offset of the x variable, into RAX so that x now stores the address of x. And then we're moving that result, the address of x, which is in the A register here, into the offset in memory where the T1 variable is. And if we look at the slides, I'll continue with the slides here now. You can see that that's actually exactly the assembly code that we're supposed to be using here. So moving RBP into RAX, adding negative 32 to RAX, and then moving that A register into the location where the memory address where the T1 variable is. And that wraps it up. So the next lecture is going to be starting with dereferencing a pointer, but this should get you started with translating pointer instructions in simple IR to AT&T x86-64 assembly.